Hello students, I am Narendra Ade from RCRT Chandrapur. In this video, we focus on projections of the plane which is inclined to one plane and perpendicular to the another plane. When plane is inclined to the one of the reference plane and perpendicular to the other plane, then its projections are drawn in two stages. In the initial state, initial stage, plane is assumed to be parallel to the reference plane, to which it has to made to be inclined. Means plane is inclined to the horizontal plane. Assume the plane parallel to the horizontal plane in the first stage, or if suppose the plane is inclined to vertical plane, then in the first stage you have to assume it parallel to the vertical plane. Then in the second stage of the problem, take a inclination of that is the plane. So therefore, whenever plane is inclined to one of the plane and perpendicular to the other plane, solve the problem in two stages. Now first take plane inclined to horizontal plane perpendicular to the vertical plane. A square plane, a square lamina ABCD of side 30 mm resting on one of its side is perpendicular to the vertical plane and inclined to 45 degrees to the horizontal plane. Draw its front view and the top view. Here square plane is inclined to 45 degrees to the horizontal plane and perpendicular to the vertical plane. If the plane is inclined to the one and the perpendicular to the other plane, solve the problem in two stages and take inclination of the plane in the second stage. Here plane is inclined to the horizontal plane, and from that one you decide the first stage of that plane. That is, the plane is inclined to horizontal plane. So what you will do in the first stage, assume it parallel to the horizontal plane. So you know that when plane is parallel to the horizontal plane or in a horizontal plane, the true shape of the plane is seen in that is the top view. So you have to first decide in all the problems of the plane where the true shape of the plane appear. I means in the top view or that is the front view. That position of the true shape in the front view or the top view, that depend upon the inclination of the surface with horizontal plane or the vertical plane. That you have to decide from the inclination of that surface. Here surface is inclined 45 degrees to the horizontal plane, that you have to take in the second stage of that problem. So in the first stage, take the plane parallel to the horizontal plane or in a horizontal plane, parallel to the horizontal plane or in a horizontal plane. In the previous video already you have seen when plane is parallel to in a horizontal plane and perpendicular to the vertical plane, true shape of the plane appear in a top view. Therefore, you draw the first stage assuming the plane parallel to the horizontal and perpendicular to the vertical plane. If the plane is parallel to the horizontal plane, is parallel to the horizontal plane, so that true shape of the plane that will be seen in the top view. Before that, I will visualize the position of that is in a plane. See that that is again that is in a first quadrant. That blue one is the horizontal plane, and this vertical is that white one is that is in a vertical plane, and this is the first quadrant. This is the front direction of the observation, and this is the top direction of that is in observations for the horizontal plane. So this is a dark red, that is the plane, that is the square plane. It is inclined to horizontal plane. See that one, the inclination of the plane with a horizontal plane is it is a inclined to the horizontal plane, it is a perpendicular to the vertical plane, Now here plane, whenever plane is inclined to the horizontal plane, its inclination is seen in that is in a front view. Okay, you can observe the inclination of that is in a plane. As it is inclined to the horizontal plane, that inclination seen in that is in a front view. See that in the front view you will get that is an inclined line making the same angle as the plane makes with a horizontal plane. So this angle is the 45 degrees. Then this is the front view line. If the plane is perpendicular to the vertical plane, projection of that plane on a vertical plane must be the line, already you have seen that when plane is parallel to the any suppose a plane, then its projection on that plane, that is the true shape of the plane, and when plane is perpendicular to the any suppose the plane, the projection on that plane is a straight line. So here is the plane is perpendicular to the vertical plane, the projection on the vertical plane means it's an a front view is a straight line, as and it is a inclined, as the plane is an inclined, therefore that line is inclined line, and it will make the same angle as the plane makes with a horizontal plane, as the plane makes with a horizontal plane. On a front view, you will get the inclined line making that is a same angle. Then project the plane on a horizontal plane to get a top view. Now see here in the top view, you will not get the actual square, you will not get the true shape of the plane. In the top view, you will get a reduced figure, you will get that is the reduced figure as plane is inclined to the horizontal plane. Plane is inclined to the horizontal plane, therefore projection on the horizontal plane is not the true shape, because when plane is parallel to the horizontal plane, then only then you will get the true shape of the plane on a horizontal plane. Here plane is an incline, therefore in the top view or on a horizontal plane, you will get the reduced figure, reduced shape, that is called the apparent shape of that is a section, that is called a reduced shape, it is called the apparent shape of that is a section. Now we will solve this in a problem. First you have to draw that is an XY line. Already I have already explained that here in the first stage you have to take the plane parallel to the horizontal plane, yeah, in horizontal plane. Here the side is resting on the one of the side on a horizontal plane. Therefore what will do, assume the plane in a horizontal plane. Assume the plane parallel to the horizontal plane, in a horizontal plane. If the plane is in a horizontal plane, therefore true shape of the plane in that is in a top view. So first you draw the sphere of the given side, here 30 millimeter side, in the top view any distance below the xy. Then project it up to the xy line only. You draw the front view line on the xy as plane is in a horizontal plane. When plane is parallel to the horizontal plane, then this front view line you have to draw parallel to the xy above xy. But here plane is in a horizontal plane, that's why you have to draw the front view line in a xy. These are the projections of that is in a plane in a first stage, where plane is in a horizontal plane and perpendicular to the vertical plane. Now you draw the second stage, and in the second stage make the plane inclined to the horizontal plane by an angle of 45 degrees. Therefore what you will do, you take this is the one side and that is an xy, means in a horizontal plane, draw the line making an angle of 45 degrees, and along the 45 degrees you take the same length of the surface from the first stage. This is called the length of the surface. The same length of the surface by means of the compass you can cut along the 45 degrees. Here plane is inclined, yes, surface is an inclined. This indicate the inclination of the plane. Yes, inclination of surface of the plane with a horizontal plane. Then draw the projectors vertically to draw the top view, and from the previous top view you draw the horizontal lines and mark there the points of that is an intersection and connect that in a point in the correct sequence. Then whatever the figure obtained, that figure is the required top view. That figure is the required top view. See that in the top view you are not getting the square. Now it is the reduced figure, smaller than the true shape of that is the plane. That must be the rectangle. In the first stage, the true shape in the problems of projections of the plane, true shape of the plane always appear in the first stage. It may be the one stage problem, two stage problem, it may be the three stage problem. The true shape of the plane always appear in the first stage. This is the first stage. In the top view there is this one is the true shape of that is a plane, which is that is a square. And in the second stage, after making the plane inclined to horizontal plane, in the top view you are getting the reduced figure, that is called the apparent shape of that is a section, that is a smaller than the square. Smaller than the square means it must be the rectangle, because if the plane is inclined to horizontal plane. Plane is inclined to the horizontal plane, inclined to the one plane. Therefore, this figure get reduced in a one direction only. It get reduced, that is a horizontally, vertically remain, that is the same. Vertically remain, that is the same. So that's why this is over the 30 millimeter. This 30 will remain the same, and this is the 30, that get reduced. So that how much reduction, that will depend upon the inclination of the surface. The more inclination, this is the more reduced figure. Suppose the less inclination, what is the minimum inclination? That is a 0. It is a 0, then in that case plane is in a horizontal plane, or parallel to the horizontal plane, then in that case no reduction. Therefore this figure will, as it is, that is a true shape of that is a plane. The reduction of that is in a plane, reduction of the figure, that depend upon the inclination of the surface. The surface inclination, if there is a more surface inclination, plane is inclined, more surface inclination, then that figure get reduced more. If it is a less inclination, figure get reduced over the less. In this other way, you can draw the projections of that is a plane when plane is inclined to one plane and perpendicular to the another plane. You have to draw the projections in that is in two stages, and the inclination of the plane always you have to take in the second stage of that is a problem, and in the first stage you take the plane parallel to the that plane to which plane is inclined. Plane is an inclined. So remember that whenever plane is inclined to the one and perpendicular to the other plane, you have to solve the problem in two stages, and always start the problem by drawing the true shape of the plane in the front view or in the top view in the first stage. That depend upon the to which plane you are taking the plane parallel. Plane is here parallel to the horizontal plane, true shape of the plane in that is in a top view, or when suppose the plane is given inclined to the vertical plane. So what will you make, what assumption will you make? You assume the plane parallel to the vertical plane, so that true shape of the plane in the front view. So starting of the problem by trying the true shape of the plane in the front view. From which will start the problem, that depend upon the inclination of the surface in that is a second stage. When plane is perpendicular to the one of the reference planes and inclined to the other plane, its inclination is shown by an angle which its projection on that plane to which it is a perpendicular and makes with a xy. In the last problem, that plane is perpendicular to the in the last problem, here plane is perpendicular to the vertical plane. Plane is perpendicular to the vertical plane. That's why in a front view projection on the vertical plane, there is the line making the same angle as the plane makes with a horizontal plane. Its projection on the plane to which it is an incline is smaller than plane itself. Now see here, plane is inclined to the horizontal plane. Therefore, projection on the horizontal plane, that is a reduced figure. That is a reduced figure. That is the apparent shape of that is a section which is smaller than the true shape of that is a plane. That we can observe in the second stage. In that is the top view in this problem. Take a problem. A regular pentagon of 25 mm side has one side on the ground. The ground means horizontal plane. Its plane is inclined 45 degrees to the horizontal plane and perpendicular to the vertical plane. Draw its projections. To solve that is a problem, you first search the surface inclination. See that is the surface inclination to which plane surface is inclined. Here that plane means that is the surface is inclined at 45 degrees to the horizontal plane. So this is the very useful that is the data to solve the problem of the plane. To solve the problem of the plane, you have to decide the true shape of the plane in that is the first stage. In the always you have to draw the true shape of the plane in that is the first stage, and that is the starting of every problem of projection of that is in a plane. Now plane is given 45 degrees to the horizontal plane. Plane is given 45 degrees to the horizontal plane. That's why it will appear in that is in a front view. In that is the second stage. What assumption you will make? You take the plane parallel to the horizontal plane. Parallel to the horizontal plane, yeah, in a horizontal plane. Here one of the side is given in a horizontal plane. That's why instead of taking parallel, you take in a horizontal plane. So here you can observe this one, A dash, B dash, C dash, this line. That is the plane. That is the surface. It is in a horizontal plane. You know that one, when plane is in a horizontal plane, its true shape is seen in the top view. True shape is seen in the top view. You follow this and a faint and a pentagon, not that is a dark pentagon. What you will do in the problem, you first draw the regular pentagon of the side of 25 mm side. In the top view is the true shape of the plane. And position of the pentagon, that also you have to decide. Here one of the side is taken, that is in a vertical. Every time that pentagon not remain in the vertical position, that depend upon that is in a data given on which it is resting. Here that pentagon is resting on the one of the side. Pentagon is resting on the one of the side on the ground, yeah, on the horizontal plane. Therefore it is a sideways problem. It is a sideways problem. Therefore what you will do, you draw the pentagon or any polygon. Any suppose a polygon, any suppose that is in a plane, any suppose a plane with a one side remain that is a vertical, yeah, perpendicular to the xy. You have to remember, whenever sideways problem is in a given there, you have to draw the true shapes that in a polygons, yeah, planes with a one side keeping vertical means perpendicular to the xy line. Here you draw the one line perpendicular to the xy, and about it draw the regular pentagon, that is the true shape of the plane, that is the true shape of that is the plane. Then project it up to the xy line and obtain the front view of the plane. This is the front view of the plane, that is the line in a xy. As you are assuming the plane in a horizontal plane, assuming the plane in a horizontal plane. Then in the second stage, this end of the line represent, there are the 2 points, a dash and the e dash, that represent the side of the plane, that represent the side of that is in a plane. Take that in a side in the second stage on the xy line, means that you have taken one of the side, here side AE in a horizontal plane, and the plane is inclined 45 degrees to the horizontal plane. You can observe in the same problem, this is the surface, this is the front view of the plane. On the right side there is the single corner, there is the C dash. If it is a single point C dash here, that represent a corner of the plane. And on the left side there is the, though E dash is not shown here, but there is the A dash and the E dash, that is the front view of the line E, because that side AE, yeah, line AE is perpendicular to the vertical plane and in a horizontal plane, so its front view, that is a point and it will lie in a xy line. Here though it is the point, along it, that is the front view of the side AE, there are the A dash and the E dash. This end represent the side, and as there is a single point at the right end, that will represent the corner of the pentagon, corner of that is the plane. In the question there is given side is in a horizontal plane. Therefore don't mistake, don't take the C dash on the xy, that will be wrong. If you take the C dash in a xy, means you have taken the corner in a horizontal plane. Here given the side in a horizontal plane. Therefore take the this same A dash and the E dash on xy in the second stage. Draw the line making the 45 degrees, and along the 45 degrees you take the same length of that is in a surface by means of that is in a compass. Dark this in a line, that also represent the vertical trace of the plane, that also represent the vertical trace of the plane. Okay, then after drawing the front view, you draw the projectors to get that is suppose the top view vertically, and from the previous top view you draw the lines parallel to the xy. Mark there the points of that is the intersection. Obtained is A1, B1, C1, D1 and the E1. This is figure, it is not that is a regular pentagon, it is the reduced figure, it is a smaller than that is the first figure. This is the final top view of the plane. The projections, front view is the line making the 45 degrees, and the top view is the reduced pentagon. These are the final projections of the plane, final projections of the pentagonal plane, which is 45 degrees to the horizontal plane, perpendicular to the vertical plane, and one of the side is in a horizontal plane. See that one, whenever plane is inclined to the one and the perpendicular to the other plane, the in the top view, to each plane it is an inclined. Here plane is inclined to the horizontal plane. The projection on the horizontal plane in the top view, you will get the reduced figure. You will get the reduced figure. Take opposite one. Now plane is inclined to vertical plane and perpendicular to the horizontal plane. Take suppose the problem is square ABCD is perpendicular to horizontal plane and inclined at an angle of phi to the vertical plane. You know that inclination of the line, inclination of the plane in orthographic projections with a vertical plane is represented by the phi, and with a horizontal plane it is represented by the theta. These are the unit notations you have to follow. In the orthographic projection, whenever theta was given, the theta stand for the inclination with a horizontal plane, and the phi stand for the inclination with a vertical plane. See this figure. This is again, that is a quadrant. This shaded one, this is the plane. The see, it is in the vertical plane, means it must be the perpendicular to the horizontal plane. It must be the, as it is a vertical, it must perpendicular to the horizontal plane. And you can observe that one, that this is the vertical plane. To the vertical plane it is an inclined this much angle, phi angle, it is shown the phi angle. That angle is in that plane is inclined to the vertical plane. Plane is inclined to the vertical plane and perpendicular to the horizontal plane, perpendicular to the horizontal plane. Now project on the horizontal plane. Here you will get that is in a line. You will get that is in a line, and project on the vertical plane. You will get that is in a front view. That is the reduced figure. That is the reduced figure. So in this one, directly second stage are drawn there. It is for the visualization point of the view. Directly the final projections are drawn here. So in that is in a front view. It may, if this is about the sphere, then this figure is the smaller than the sphere. It may be the rectangle, or this plane is about the rectangle, then it may be the square. That depend upon the front view. That depend upon that is in the plane that is in a given. But that must be the reduced figure. Here projections are drawn. That is the directly. With the help of that is the problem, I will explain how to draw the projection. Just to understand from this, and suppose that is the quadrants. After getting the projection, these projections are drawn directly here. So in the front view there is the reduced figure, which is the apparent shape of the plane, and in the top view there is the line making the same angle as the plane makes with a vertical plane. Better way, I will explain with the help of that is the plane. Here we will take a circular plane. Okay, until now you have taken that is a polygonal planes. Now we will take that is a circular plane. Draw projections of a circle of 50 mm diameter having its plane vertical. Vertical means perpendicular to the horizontal plane. Inclined at 30 degrees to the vertical plane. 30 degrees to the vertical plane. Its center is 30 mm above horizontal plane, 20 mm in front of the vertical plane. Okay, the center of the circle is that is in a point. Already you have studied the projections of that is in a point. So with the help of the projections of the point, you can draw the projections of center of that is in a plane, which is the point is 30 mm above horizontal plane and the 20 mm in front of the vertical plane. So that one you will get that is in a, you have here, instead of drawing that is in a true shape as a circle anywhere from the xy line, the center is an given. Therefore you have to first draw the projection of that is in a center of the circle. The center is the center is the point. That point is 30 mm above horizontal plane and the 20 mm in front of the vertical plane. Therefore its front view above the xy by the distance of the 30, and its top view 20 mm below the xy is that point. Yes, center it will lie in that is in a first quadrant. Here center is denoted by the point O. See here, O dash is taken 30 millimeters above the xy line, and the O, which is the top view of the center, that is taken 20 millimeter in front of the VP, and 20 millimeter in the top view from the xy line. Then we will visualize that is suppose a question, how to start, that is a problem, where to draw the true shape of the plane. That you have to decide. First you have to decide in any question where to draw the true shape of that is in a plane. I means in the first stage, but in the front view or in that is in a top view. So for that one you first see there the surface inclination, you have plane inclination. So here plane is inclined to the vertical plane. Main data is the plane inclination. Plane is inclined to the vertical plane. So you know that inclination of the plane in all the problems of projections of the plane you have to take in the second stage of that is a problem. The plane is inclined to the vertical plane. So you have seen when plane is inclined to the vertical plane, its inclination is seen in the top view. Seen in that is in a top view. Therefore in the second stage you have to take the plane in inclination. So here plane is inclined to the vertical plane. Plane is inclined to the vertical plane. So what will I do? In the first stage, you take the plane parallel to the horizontal plane. You take the plane horizontal plane, sorry, parallel to that is a vertical plane. If the plane is inclined to the vertical plane, therefore you take the plane parallel to the vertical plane, parallel to the vertical plane. And you know that one, whenever any plane parallel to the vertical plane are in a vertical plane and perpendicular to the horizontal, yet the true shape of the plane is in the front view. True shape of the plane in the front view. In this other way, you have to first decide where to draw the true shape of the plane. I means in the front view or in the top view. Here plane is inclined to vertical plane, therefore you first take plane parallel to the vertical plane. Whenever plane is parallel to the vertical plane, true shape of the plane appear in the front view. Therefore you first draw the true shape is a circle, actual that is in a plane, in that is in a front view. Already you have drawn the projections of the center of that is in a circle, which is 30 millimeters above horizontal plane and 20 millimeters in front of the vertical plane. If suppose this center of the circle is not given, then there is a no question, you can draw the circle anywhere, means any distance above the xy line. But here center is specified, therefore about the center you have to draw the circle. Take the center O dash, and here diameter is the 50, means radius of the 25, and draw there the circle. A circle don't have that is in a corner or don't have that is in a edges, only that is in a curved surface. To draw that is in a suppose the figures projections in that is the second stage. So what will I do? You take number of points on the circumference of the circle. So for that way, better way you take the 12 number of points along the circumference of that is in a circle. You will divide the circle in a 12 number of the parts. You take the 12 point, even you can take the 8 point, that depend upon that is in a u. You better way take the 12 number of points along the circumference of that is a circle. Name them 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, as it is the front view. Then project this on the horizontal plane. On the horizontal plane means on the top view, you will get a line, and here again it is given 20 in front of the VP. Therefore this line, now you cannot draw on that then suppose the XY line. You can draw on the XY line only the when plane is in a vertical plane, in a vertical plane. But here you have to take the plane parallel to the vertical plane. Therefore some distance, here how much distance? 20 meter. Here plane is 20 millimeter in front of the VP and parallel to the VP. What is the correct position? That plane is 20 millimeter in front of the VP and parallel to the VP. Therefore here you have to draw the top view 20 millimeter from the XY and parallel to the XY. Then in the second stage, again you have to turn that in a plane, you have to make the plane inclined to the vertical plane about the point O, about the center. Therefore passing to the center, draw the line making the 30 degrees, and along this 30 degree line mark this NS over the points on the surfaces. 0 to the 7 on the right side and the 0 to the 1 on the left side are some other remaining point. This is the line as it is in the top view, that is the horizontal trace of that is the plane. You know that horizontal trace of the trace of the plane is the line, and again you know that trace of the line is the point. You have to remember, trace of the line is a point and the trace of the plane is a trace of the line is a point and the trace of the plane is that is a line. So whenever line view, that represents the one of the trace, and when it is in the top view, that represents the horizontal trace. So there is a line in the front view that will represent the vertical trace of the plane, that represents the vertical trace of the plane. That is the intersection of the plane with the horizontal plane, with that is a horizontal plane. Then what you will do, you project this project vertically to get that is the front view. Also draw the lines parallel to the XY from the previous front view. Mark this point of intersection. Then you will get the name that 1 1 dash, 2 1 dash, 3 1 dash. Then connect all these NF points in a correct sequence by means of the smooth curve. By means of that is a smooth curve. That's why to get a smooth curve, take more number of that is the points. You can connect by means of the freehand, or you can use to get that is the more smooth curve. You can use that is a French curve. In the drawing, to draw the smooth curve, you can use one of that is a tool or device that is called a French curve. Here after connecting, you will get that is an ellipse. You will get that is an ellipse, which is the smaller than that is in a circle, smaller than the circle. Here true shape of the plane, that is the circle, and this ellipse is the apparent shape of that is in a circle. If the plane is inclined to the vertical plane, in the front you will get the apparent shape of the plane, apparent shape in that is in a front view. or oppositely when plane is inclined to the horizontal plane, the apparent shape will get in that is a top view. Again see that one, though it is the reduced figure, but vertically remain the same. This vertical diameter that remain that is the same, that is equal to that is the major axis, and this horizontal diameter get reduced, and that is called the minor axis of that is an ellipse. So vertically figure remain the same, and the horizontally remain in the vertically remain the same, and horizontally get that is reduced if the plane is inclined to the one plane only. So whenever plane is inclined to the one plane, it get reduced in a one direction only, one direction only. Let us see when plane is suppose inclined to the both the plane, what happened to that in a reduce suppose a figure. Obviously that will be the reduce in a both that is in a direction, vertically as well as that is in a horizontally when plane inclined to both horizontal plane and that is the vertical plane. That will see in that is the next suppose a video. Okay.